Illustration of density contrast model for Cauchy type integral representation. Using the integral transform approach, such gravity anomaly can be represented as follows. Where hx, y, is the relative elevation between the surface gamma and plane P at each horizontal location, delta rho is the density contrast between these two layers, which is also the anomalous density inside domain dr, C gamma rr, hx, y dz, is the 3D Cauchy type integral on the surface of gamma for the vector function hx, y dz, at the point of r. Mathematically, the 3D analog of Cauchy type integral for the vector function phi, r, can be defined as follows. Where S is some closed surface which bounds a 3D domain D, phi, r, is some vector function defined on the surface S. The 3D Cauchy type integral itself is a vector function which satisfies the following equation outside the domain D, which is bounded by surface S. These important properties make it possible for using the 3D analog of Cauchy type integral to construct solutions of gravity problem. Using the scalar representation of 3D Cauchy type integral, one can write the solution of gravity field caused by the model shown in as follows. Where each of alpha, gamma, eta can be equal to x, y, z, pre the projection of gamma rho on the horizontal plane P. The 4-index delta symbol is defined as follows. The parameter b gamma is defined as follows. Note that the model described in is exactly a typical sediment-basement interface model when the horizontal plane P is on the Earth's surface. By taking the spatial derivative of 14, one can find the expression of gravity gradiometry data using 3D analog of Cauchy type integral transform. Clearly, we can see that the 3D gravity modeling problem can be reduced to the surface integral over the density contrast surface using the Cauchy type integral approach. As a result, the computational cost can be reduced significantly comparing to the direct integral method. As a matter of fact, this method works for a complex distribution of density contrast over vertical direction. In this case, it only requires the density contrast function in vertical direction to be integral.